to Shree Krishna Educational Channel. In this video, I am going to explain about the physical properties of amines. Methylamine, ethylamine are the simple amines. Those are present in the gases at room temperature. At the same time, those are also having the ammonia-like smell. Okay, similarly, the other amines, those are present in the liquid state and which has the raw fish-like smell. There are some other simple amines. Okay, those are irritating to the skin, eyes, and mucous membranes and are toxic by injection to the body. Aromatic amines, generally those are toxic in nature. The many amines are readily absorbed through the skin, affect both the blood as well as the central nervous system. The lower aliphatic amines, those are gases and also has fishy odor. The primary amines, okay, with 3 or more carbon atoms are liquid and still higher ones are solid state. Aniline and other aryl amines are usually colorless but get colored when stored in the case of the atmospheric oxidation. So that case it would be get colored. Lower aliphatic amines are soluble in water because they can form hydrogen bond with the water molecules. You can see here the amine which is having the pair of electron, so it can has the hydrogen bond with the water molecule because here hydrogen has less electron density around the hydrogen in the water molecule, so it can form this partial bond with the pair of electron. Similarly, the hydrogen of amine which also forms the hydrogen bond with the oxygen of the water molecule. So, okay, which is the presence of these hydrogen bonds in the case of water molecules, it can increase the solubility. Solubility that should become increases in case of the amines, but the solubility in the water molecule that would be decreases with increasing molar mass of amines, that is due to the increase in the size of hydrophobic part. As the alkyl part that should become increases, then the solubility in the water that would become decreases. The higher amines, okay, which are essentially insoluble in the case of water. The electronegativity of nitrogen in the case of amines as well as oxygen in the case of alcohols, which are 3.0 and 3.5. So you can notice here the nitrogen electronegativity which is 3.0 and the oxygen electronegativity is 3.5. So based on this you can easily predict that the more polar nature in case of the alcohols rather than that of the amines. Because of this reason, the alcohols which are highly soluble rather than the amines. The higher alcohols, certain extent which can be soluble in the water than amines. Next, the amines which are soluble in the organic solvents like alcohol, ether, benzene, CCl4 carbon tetrachloride as well as CHCl3 chloroform. So these solvents which can be soluble because those are the non-polar solvents. But the alcohols which are more polar than that of the amines and form stronger intermolecular hydrogen bonding than amines. The primary, secondary amines, those are engaged intermolecular association, that is due to hydrogen bonding between the nitrogen of one molecule and the hydrogen of other molecule. So you can notice here the nitrogen of one amine and the hydrogen of other amine. So between that it can be forms the hydrogen bonds. So due to these the primary and secondary amines, those are having the intermolecular hydrogen bonding. The intermolecular hydrogen bonding which is more in the primary amines than secondary amines, because here the primary amines which has two hydrogens are available. In the case of secondary amines which are having the only one of the hydrogen is available. So due to these which are responsible for the hydrogen bonding. In case of the tertiary amines which do not have intermolecular association, that is due to the absence of the hydrogen. Because here in case of the tertiary amine, so there is a 3 alkyl groups present on the nitrogen, there is no hydrogens. So due to this the hydrogen bonding which is not possible due to absence of hydrogen. Based on this hydrogen, in the case of amines, the boiling point also that should become varies. The order of boiling points, the isomeric amines which is as primary is more than secondary than tertiary. So primary amines have more boiling point than secondary than tertiary amines. So you can notice here the 1 amino butane, it is molecular mass is 73. Second one is n ethylamine, it is 73, and other one is n dimethyl ethylamine, it is also having the 73. These are the isomers. And other one is 2-methyl butane, it has the 72 molar mass, and other one is the 1-butanol, it is 74 molar mass. Okay, if we compare the boiling points, the boiling point of the 1 amino butane which is 350.8, whereas n ethylamine which is having 329.3. Next one is 2-methyl n dimethyl ethanamine, it is having 310.5. And the fourth one which is 2-methyl butane has 300.8, and the alcohol which is butane 1-ol has 390.3. So among these, butane 1-ol has the maximum boiling point, though it is a similar molar mass, but the amines have less when comparing with it. But within the amines, if you compare the n-butylamine which is having the more boiling point than the remaining. This is about the boiling point variation. So because of this, the primary amines which has more boiling point than secondary than tertiary, because it is more possibility for the hydrogen bonding. But the amines has less boiling point than that of the alcohols. This is about the physical properties of amines. Thank you.